Hello and good day, everyone. Welcome back to my YouTube channel. This is Sir Marcy, and our lesson for today is all about simplifying exponential expression, wherein we're going to apply the laws involving positive integral exponents to zero and negative integral exponents. Are you guys ready? Let's try to simplify first the following using the laws of exponent. In number one example, we have a raised to 3 multiplied to a raised to 5. We apply the product rule wherein since they have the same base, we're going to add the exponent. So the answer here is a raised to 8. Very good. Next, in this example, we are going to apply the quotient rule wherein since they have the same base, we're going to subtract the exponent. So the answer here is a raised to 5m minus 3m. And the answer is a raised to 2m. Next, we have the quantity of 4a raised to the second power. We're going to apply here raising product to a power rule wherein we will apply distributive. So we will distribute the exponent to each base. So we have here 4 raised to 2, then a raised to 2. We know that 4 raised to 2 is equal to 4 times 4, and that is 16a raised to 2. Next, the next example, we have x raised to 4 raised to the fourth power is an example of a power to a power rule, wherein we're going to multiply the exponent. So we have x raised to 4 multiplied to 4, and our answer is x raised to 16. And lastly, we have raising quotient to a power rule wherein we're going to apply also distributive property. So that's b raised to 3 multiplied to 2 all over 7 raised to 2. Then we simplify. That's b raised to 3 times 2, which is 6, all over 7 squared, which is equal to 7 times 7. And the answer is 49. Okay, so there you have it. I hope you remember the different laws of exponent we discussed in our previous lesson. Okay, this time we're going to apply these laws in simplifying negative and zero exponents. Okay, here are the different laws of exponent we already discussed in our previous lesson. First, we have the product rule. It simply states that to multiply exponents having the same base, we simply add the exponent. So from here, a raised to m multiplied to a raised to n, that's equal to a raised to m plus n. Also, we have the quotient rule. It simply states that to get the quotient, here, we simply subtract the exponent if they're having the same base. Next, we also have power to a power rule. It is actually a raised to m raised to another power n. So to get the product here, we simply multiply the exponents. Also, we discuss about the product to a power rule. So in this case, the quantity of a, b raised to the power of m, we apply distributive property. No? So we distribute each exponent to each base. So that's a raised to m multiplied to b raised to m. And lastly, raising quotient to a power rule. If we have a all over b raised to m, so we also distribute each exponent to each base. So that's a raised to m all over b raised to m. Also, we discuss about the zero exponent. If a is a non-zero number, then a raised to 0 is equal to 1. It means that any number raised to a power of 0 is equal to 1. And lastly, the negative exponent. If n is a positive integer and a is a non-zero real number, if that's a raised to negative n, a or negative n, that's equal to 1 all over a raised to n. So we're going to get the reciprocal and make it a positive exponent. Okay, so let's now proceed with our lesson. That's how are we going to simplify exponential expression. To simplify each expression. In letter A, we have 7x raised to 0. If you still remember, any number raised to the power of 0 is equal to 1. So here, we can simplify this as 7 multiplied to 1. And the answer is 7. In this case, since this is enclosed in a parenthesis and raised to a power of 0, that is equal to 1. So if we're going to expand it more, we can apply, we can distribute the exponent. So the 7 raised to 0, x raised to 0. And we know that 7 raised to 0 is 1 and x raised to 0 is 1. So 1 times 1, the answer is still 1. Example number 2. Evaluate each numerical expression. In letter A, we have negative 5 raised to 0. If we still remember, any number raised to the power of 0 is equal to 1. So here, negative 5 raised to 0 is equal to 1. In letter B, to solve for this, we will apply or we will distribute 3 to negative 2. So apply power to a power rule. So that's 2 raised to negative 2 multiplied to 3, which is equal to 2 raised to negative 6. And then we apply negative exponent wherein we're going to get the reciprocal of 2 raised to negative 6. That is 1 all over 2 raised to positive 6. And lastly, we're going to evaluate 2 raised to 6. That's 2 times 2 times 2 times 2 times 2 times 2. And the answer is equal to 1 all over 64. Next, we have number 3. We apply the same steps in letter B. So we multiply negative 2 and negative 3. So that's 3 raised to negative 2 multiplied to negative 3. The answer is 3 raised to 6, positive 6. If we evaluate 3 raised to 6, that's equal to 729. And lastly, we have letter D. So what we're going to do is we will again distribute negative 4. So that's 3 raised to negative 4 all over 2 raised to negative 4. Then we get the reciprocal since these are all raised to negative. So that's 1 all over 3 raised to 4 all over 1 all over 2 raised to 4. And if you still remember, if we're going to divide like this or fractions, we get the reciprocal of the denominator. That's now 1 all over 3 raised to 4 multiplied to 2 raised to 4 all over 1. So that's now 2 raised to 4 all over 3 raised to 4. Then we simplify. 2 raised to 4 is equal to 16 all over 3 raised to 4, which is equal to 81.